In this video, we compare the sine function with the hyperbolic sine function, where our w's range from 0.6 to 1.4. So we begin with the values of w. Data validation, list of items from 0.6 to 1.4. We can start with 0.6. Now the data set of the sine function. This will be array formula. Sine of w times x. W times x. And we continue with the hyperbolic sine, which is the imaginary part of the hyperbolic sine of 0 plus wxi. We begin with the complex part, which is also array formula. Complex. That's 0 plus wxi, so it is 0. Now this is xi, so comma wx. Now we can apply the hyperbolic sine. So this will be IMSINH. That is hyperbolic sine of the complex number. And so we have a complex number as a result. So we take out the imaginary part. So we use the imaginary function. Imaginary function. That's the imaginary coefficient of a complex number. And we chart this. Insert chart. And we use scatter chart, so we remove the title. We don't need the title. Under the series, show the trend line. The type of the trend line, polynomial. The degree, tenth. For the label, use the equation. For the legend, position at the left. Here's our trend line and the polynomial of the sine function. We can change the value of w to 0.8. That's for the sine function in blue. The wavelength is now shorter. Change also the hyperbolic sine, w. Now they're the same. Change this to 1, w equals 1. We'll do the same thing to hyperbolic sine. Now they're the same. Change the w for sine to 1.2. We can also change this to 1.2. Change this to 1.4. We can also do the same thing. Now they're the same. So this completes the use of the functions complex, imaginary, IMSINH, sine to compare the trigonometric sine and the complex hyperbolic sine function.